Hello there, and welcome back to Sleepy Science Stories. I'm glad you're here, resting, listening, letting the day slowly fade behind you. Outside, the world quiets down. Inside, only your breathing remains, steady, calm, like the rhythm of the universe itself. Tonight, we'll drift through the stars once more, not chasing light, but following its origins. This time, we'll listen to the story of the elements, the hidden chemistry that built the cosmos, and you. Take a slow breath in, and let it go. Feel your body soften, your shoulders loosen, your thoughts spread out like dust across the dark. Imagine the silence before everything began, before planets, before stars, before even atoms existed. A universe of pure potential, waiting for its first spark of matter. Now, see it forming, a newborn cosmos, glowing with energy. Tiny particles collide, join, and fuse. Hydrogen appears, the first whisper of substance. Then helium, soft and light, fills the expanding sea of space. In this endless void, these simple atoms will one day create everything: stars, oceans, mountains, and you. How did this simplicity become complexity? How did fire create gold, and light create life? The answer lies in the hearts of stars, in the fusion that burns quietly for billions of years, weaving elements from pure light. Each atom around you carries a memory of that process, a cosmic signature of its birth. Tonight, as you close your eyes, let's follow that journey, from the first atoms of the Big Bang, through the furnaces of ancient suns, to the chemistry that now flows within your veins. Every breath you take is part of an unbroken story, a story written in starlight, told in the language of elements. So now, let's begin, the elements, chemistry of the stars. And let the universe whisper you to sleep.
In the beginning, there was only energy. Before time had rhythm, and before space had shape, there was only energy, pure, unbound, and weightless. It wasn't light, not yet, because light needs space to move through. It wasn't sound either, because sound needs air. It was something deeper, a trembling potential, an unspoken note before the first chord. From this nameless energy, the universe would soon unfold. It was neither dark nor bright, because darkness and brightness did not yet exist. The beginning wasn't an explosion as we imagine. It was an expansion, a breath from nothing into everything. In that breath lay the blueprint of every star, every ocean, and every thought that would one day rise in curious minds like ours. The newborn universe was too hot for atoms to exist. Moments after that first expansion, temperatures were so immense that no atom could survive. Particles rushed about in chaos, colliding, breaking apart, merging again. Imagine a sea of light so dense that even time seemed to wade through it. In this fiery infancy, the universe was a plasma, a fluid of energy and potential. Every inch of it glowed brighter than a million suns. The laws of physics were already at work, invisible sculptors guiding chaos toward order. Slowly, as it stretched outward, the universe began to cool, like metal losing its red heat. The first possibility of matter began to flicker within the cosmic fire. As it cooled, protons and neutrons formed, the seeds of matter. Cooling brought stability. Out of energy, particles found each other, protons with their positive pull, neutrons with their quiet balance. They danced together, bound by the strong nuclear force, one of the universe's most mysterious powers. Each bond was fragile at first, easily broken by surrounding heat. But as expansion continued, more and more of them held together. These small nuclei were the first things, no longer pure energy, but tangible, enduring. They were like pebbles forming in a stream that had always been vapor. From these seeds, the rest of the cosmos would grow. Hydrogen was the first element to appear. At last, When the universe was about 3 minutes old, the first hydrogen atoms emerged. A proton caught an electron and formed the simplest atom possible, one positive, one negative, bound together in harmony. Hydrogen was humble, but it would become everything: the fuel of stars, the foundation of water, the heartbeat of life. Even now, 3/4 of the universe remains hydrogen. When you see a star shining in the night sky, what you're really seeing is hydrogen transforming, releasing the light that once slept in the dark fabric of the Big Bang. Then came helium, forged in the first 3 minutes. In the heart of that newborn fire, hydrogen fused into something new: helium. It took unimaginable pressure, the kind only the universe itself could provide. Helium was smoother, more elegant, a pair of protons and a pair of neutrons, stable, calm. In those first 3 minutes, the universe made most of the helium it would ever have. The process is called Big Bang nucleosynthesis, a gentle term for a violent miracle. And as the expansion continued, the creation slowed. The furnaces of the first stars had not yet ignited, but the raw materials of their flames were already here. A trace of lithium joined them, rare and delicate. Lithium appeared only in whispers, fragile and fleeting, formed in the brief window when the temperature was just right. Too hot, and it would shatter. Too cold, and fusion would fail. But a few atoms survived, scattered like rare jewels in a vast ocean of hydrogen and helium. Lithium would later find its home in stars and in the hearts of planets. It's strange to think that this light metal, one day used in batteries, in the pulse of modern technology, first arose in the ancient fire of creation, billions of years before life ever dreamed of electricity. No heavier atoms yet. The universe was simple. For a long time, that was all there was: hydrogen, helium, and traces of lithium. No carbon, no oxygen, no iron, not even dust. Just pure gas, drifting endlessly. Yet within that simplicity lay infinite potential. Like the alphabet of a language not yet spoken, these 3 elements waited for their story to begin. They floated through vast emptiness, guided only by gravity, the quiet hand of the cosmos, invisible but patient. The universe was young, quiet, and empty of color. But that emptiness was fertile. It was preparing for stars. 99% of early matter was hydrogen and helium. If you could have stood in that infant cosmos, though there was no ground to stand on, you would have seen nothing but thin, glowing mist. Hydrogen and helium filled almost all of existence, smooth and uniform. The remaining 1%, lithium, neutrinos, photons, seemed like mere decoration. But in that 1% lay the seeds of everything complex. The universe was a minimalist painting, a simple palette from which nature would mix all future colors. It's humbling to realize that everything we know, mountains, oceans, dreams, emerged from that feigned imbalance. These elements drifted into vast clouds of gas. As the universe cooled further, gravity began to draw these particles together. The result was immense clouds, nebulae, stretching light years across. Within them, gas moved like smoke underwater, coiling and folding. Density gathered at random points, where more particles attracted more still. In these silent regions, the first stars would someday ignite. These clouds were the universe's womb, invisible in darkness, yet alive with motion. Even now, telescopes can see their descendants, the Orion Nebula, the Eagle Nebula, places where matter still dreams of becoming light. Gravity began to gather them into stars. Gravity, the quiet sculptor, never rests. Over millions of years, it drew the gas clouds tighter. The pressure increased. The centers grew hotter. Motion turned to tension, and tension to fire. In the hearts of these collapsing clouds, the first stars were born. Their light marked a turning point, the end of the cosmic night. For the first time, the universe had structure, contrast, and rhythm. Every flicker was gravity's victory over emptiness. Energy made visible, order born from chaos. The stars became the universe's first furnaces. Inside those newborn stars, temperatures soared to millions of degrees. Hydrogen began to fuse again. This time, not in a cosmic explosion, but in the steady heartbeat of stellar cores. Each fusion released photons, which traveled outward, bouncing countless times before escaping as starlight. These were the first real fires in the dark, controlled, radiant, eternal compared to human time. Every star was a laboratory, crafting new elements atom by atom. What began as physics became chemistry, and what began as chemistry would one day become life. Inside them, fusion began, the birth of new elements. Fusion is balance, the inward crush of gravity matched by the outward push of light. In this delicate dance, hydrogen atoms merge to form helium, releasing tremendous energy. But as stars age, they begin to create more carbon, oxygen, nitrogen, slowly, steadily. The universe, once composed of only 3 elements, began to diversify. In the glowing interiors of stars, matter learned complexity. The elements are not just physical. They are stories of endurance, patience, and transformation written in nuclear fire. Every spark of starlight meant hydrogen was fusing. When you look up and see a star, what you see is fusion made visible. Trillions of hydrogen atoms joining together every second. Each flicker is a whisper of creation continuing. The same process that lit the first stars still burns in the sun today. That sunlight touching your skin began in the sun's core millions of years ago, journeying through layers of plasma before escaping into space, finally reaching you, across time, as warmth. In that warmth, the past still glows. The universe went from darkness to glow. There was a time before stars, a time cosmologists call the cosmic dark age. Then, one by one, stars ignited, filling space with light. The universe's first sunrise. Galaxies began to form, glowing islands in an endless sea. The photons from those first stars still travel today, faint and ancient, carrying with them the memory of dawn. The glow of existence had begun, and the universe would never be dark again. The first stars lived fast and died young. The earliest stars, called Population 3, were enormous, hundreds of times more massive than our sun. They burned through their hydrogen in mere millions of years. Their brilliance was brief, but transformative. When they died, they exploded violently, scattering the first heavy elements into space. These ancient stars were like the universe's first breaths, intense, fleeting, essential. None survive today, but their legacy fills the night sky. When they exploded, they scattered new atoms. The deaths of those stars were not endings, but gifts. In each supernova, matter was torn apart, flung across light years, mixed with the surrounding gas. Carbon, oxygen, nitrogen, all were released into the cosmos. These were the ingredients that future stars, planets, and living things would inherit. The explosion of one star could seed 1,000 future worlds. Even now, every atom in your body once drifted through such a cloud, carried by a shock wave older than memory. Carbon, oxygen, nitrogen, the building blocks of life, were born. These 3 elements are central to everything alive. Carbon forms the backbone of molecules. Oxygen allows energy to flow. Nitrogen builds the structures of cells. Yet all of them began in stars. Life's chemistry is stellar chemistry. When you breathe, you draw in atoms that once burned in suns. When you speak, you exhale the same carbon that once floated through a nebula. Every word, every heartbeat, is a collaboration between you and the stars. From fire came diversity. Stars gave the universe its first palette, dozens, then hundreds, then thousands of elements. Dust began to form. Molecules combined in cool clouds. The universe, once simple, became intricate. Every color, every mineral, every possibility emerged. From those stellar flames, from fire came not destruction, but creation, a paradox that defines all existence. From simplicity, complexity. All complexity begins with simplicity, given time. The universe is proof of that. 3 elements became 1,000. Randomness became structure. Heat became light, and light became form. In the quiet background hum of cosmic radiation, you can still hear the echo of that transformation. It's the faint static between radio channels, the memory of when everything began. From stars, all things. The atoms in your eyes, your bones, your blood, all were born in stars. Every heartbeat is powered by sunlight. Every breath sustained by oxygen made in stellar cores. You are, in the most literal sense, a child of stardust. The stars are not distant. They are within you, rearranged into thought and memory. To look up at the night sky is to look into your own origin story. And as you drift into sleep, you return, in spirit, to the quiet from which all things first arose. Inside every star, the temperature reaches millions of degrees. Deep within a star, heat becomes a force beyond comprehension. The temperature in the sun's core, for instance, is about 15 million degrees Celsius, hot enough to strip atoms apart, to crush them into one another. There is no solid, no liquid, not even what we call gas, only plasma, a state of matter where nuclei and electrons drift freely. In that glowing chaos, everything moves with purpose. Every flicker, every vibration, is energy seeking balance. From the outside, a star appears serene, a steady light in the sky. But inside, it is a storm, a heart of perpetual motion that has never known stillness. Under such pressure, hydrogen atoms merge into helium. Gravity presses inward relentlessly, pulling matter toward the star's center. The atoms at the core are squeezed so tightly that their nuclei, usually repelled by electric forces, begin to touch. And when they do, something miraculous happens. They fuse. For hydrogen nuclei combine to create one helium nucleus. A tiny bit of mass disappears in the process, converted directly into energy, as Einstein's equation E equals mc²2 foretold. That missing mass becomes the star's light, its warmth, its eternal radiance. This process is called nuclear fusion. Fusion is the heart of every star's life. It's not a simple burning, like fire on Earth, but a transformation, a rearranging of nature's most basic ingredients. Where fission splits atoms apart, fusion brings them together. It's the act of unity written into the laws of the cosmos. The star sustains itself through this constant balance between creation and destruction, consuming fuel, yet generating brilliance. Fusion is patience made visible. Fusion releases light, the reason stars shine. Every photon born in the core of a star begins a long journey outward. It may take tens of thousands of years to escape, bouncing between atoms in the dense plasma. When it finally reaches the surface, it bursts into space, a single wave of light carrying the memory of fusion. That light may travel for millions of years before reaching an eye, a leaf, or a sensor. Each ray you see from a star tonight was once trapped in its core, yearning to be free. And now it drifts quietly through the dark, touching worlds that never knew its origin. When hydrogen runs low, helium begins to fuse too. Stars are not eternal, they evolve. When hydrogen in the core begins to thin, gravity starts to win again, compressing the star further. The temperature rises until helium, too, begins to fuse. Now the reactions become more complex, forming carbon and oxygen. The rhythm of the star changes. Its outer layers expand. It grows redder and cooler on the surface. These are the red giants, swollen and majestic, pulsing gently like ancient lanterns in the sky. Helium fuses into carbon, oxygen, neon. At hundreds of millions of degrees, helium atoms collide with such force that 3 of them can merge into carbon. Some of that carbon captures more helium and becomes oxygen. In more massive stars, even heavier elements like neon and magnesium form. The pattern continues, each stage hotter, faster, more intense. A cosmic staircase leading from the simplest element to the building blocks of life. In the quiet language of fusion, the universe writes its chemistry. Heavier stars can forge even more, up to iron. The most massive stars are like factories running on borrowed time. Inside them, layers of fusion resemble the layers of an onion. Hydrogen outside, then helium, then carbon, oxygen, neon, silicon, and finally iron at the core. Each layer burns faster than the one before. The entire process is a race against gravity. As long as fusion continues, the star resists collapse. But when it reaches iron, the end approaches. Swiftly, each new element requires higher heat, greater pressure. Nature demands more energy for each step upward in atomic weight. The fusing of heavier elements requires higher temperature and pressure, conditions that only exist in the most massive stars. It's a beautiful paradox. To create complexity, the universe must endure chaos. Inside these stellar cores, temperatures can reach billions of degrees. Yet amid the violence, there is elegance, an order so precise that even the smallest imbalance would end everything. The core of a massive star becomes an elemental factory. Imagine a sphere of matter larger than Earth, dense enough that a teaspoon of it would weigh more than a mountain. Inside that core, atoms fuse continuously, layer upon layer, forging the periodic table from the raw hydrogen of the early universe. Every heartbeat of that star is a pulse of creation. The same reactions that make the cosmos sparkle also make it grow richer, more varied, more capable of life. Fusion balances gravity until it no longer can. A star's life is a conversation between 2 opposing forces, gravity pulling in, fusion pushing out. For millions or billions of years, they remain in equilibrium. But when the fuel runs out, gravity whispers the final word. The outer layers no longer have support. They begin to collapse inward, falling toward the exhausted core. The balance breaks, and a new kind of event begins, one that will echo across light years. Once iron forms, fusion stops giving energy. Iron is the universe's turning point. Fusing iron requires more energy than it releases, a dead end in the chain of creation. When a star's core becomes mostly iron, the fusion engine shuts down. Without its inner fire, the star can no longer resist its own weight. Gravity, silent and patient, begins its final act. The core implodes, compressing faster than thought. The universe prepares for one of its most dramatic moments, a death that becomes rebirth. The star begins to collapse under its own weight. In mere seconds, the core shrinks from the size of Earth to that of a city. Temperatures soar to billions of degrees. The collapse halts abruptly when nuclear forces resist further compression, and in that instant, the entire outer star rebounds outward. The shockwave races through the layers above, igniting them into a cataclysm of light. It's a soundless scream across space, the brief but magnificent death cry of a giant. What follows is violent, beautiful, a supernova. A supernova outshines entire galaxies for days or weeks. Its light can be seen across millions of light years. The energy released in a single explosion can equal what the sun emits over its entire lifetime. In that instant, atoms collide with such ferocity that new elements beyond iron are born: gold, platinum, uranium. Each supernova is both a destruction and a genesis, a cosmic heartbeat so powerful It resets the chemistry of a galaxy. In that explosion, elements scatter through space. The remains of the star expand outward in all directions, forming clouds of gas and dust rich with heavy metals. Over time, these clouds mix with interstellar gas, seeding new generations of stars. Every new system, every sun, every planet, carries traces of those ancient ashes. The Milky Way is filled with their memory, drifting silently between its spiral arms. Gold, silver, uranium, all born in chaos. The universe's rarest elements are born not in peace, but in violent endings. Gold and silver, symbols of beauty and permanence, come from the heart of destruction. Uranium, used to split atoms on Earth, was once created by the collision of neutron-rich matter in dying stars. Every piece of metal that glints under sunlight has known unimaginable heat, gravity, and darkness. There is poetry in that beauty itself is the product of chaos. Your jewelry once blazed in a dying star, the ring on a finger, the gold in a coin, the silver in a mirror. Each carries a history billions of years long. Long before human hands shaped them, they floated as atomic dust, forged in an explosion that illuminated the universe. When you hold something made of gold, you hold the aftermath of a supernova, starlight cooled into metal. It is a quiet reminder that creation and destruction are never far apart, only two sides of the same eternal process. Every breath contains atoms once inside suns. The oxygen you inhale was born in a star. The carbon in your lungs, too, was created in stellar cores. Even the nitrogen that fills the air around you carries an ancient pedigree. These atoms once burned in fusion, drifted through space, merged into planets, and now cycle through your body. To breathe is to connect with eternity, to exchange matter with the cosmos. You are not separate from the stars. You are their continuation. The cosmos recycles everything it creates. Nothing in the universe truly dies. Matter is never lost, only transformed. When a star ends its life, its remains become the raw material for new worlds. The cycle continues endlessly. Star, explosion, dust, star again. Even galaxies themselves follow this rhythm, birthing and devouring their own light. In this way, the universe sustains itself, a vast, breathing organism made of energy and memory. Even the star's ashes shine. Long after a supernova fades, its remnants still glow. The gases expand and cool, forming nebulae, colorful clouds that shimmer under ultraviolet light. The Crab Nebula, for instance, is the ghost of a star that exploded nearly 1,000 years ago. Its tendrils of light are made of iron, oxygen, sulfur, glowing embers in the great dark. To look at such a nebula is to see death turned into art. Creation always begins with destruction. Every ending in the cosmos births something new. The death of one star gives rise to countless others. The collapse of matter makes way for light. Even black holes, the ultimate symbol of finality, may seed new universes in their mysterious depths. The universe does not mourn its losses, it transforms them. Destruction is simply another word for change, and change is the essence of existence. In this endless cycle, every fire, every dust grain, every heartbeat carries the same message. Nothing is ever truly lost. When a star collapses, its core implodes. At the end of a massive star's life, when the fuel that keeps it shining runs out, gravity, which had been patiently balanced for millions of years, finally claims its victory. The core of the star, no longer supported by fusion, begins to fall inward. It collapses with impossible speed, compressing in milliseconds, shrinking from the size of a planet to that of a city. Inside, matter becomes so dense that atoms lose their individuality. Protons and electrons merge into neutrons. This implosion is silent across space, but if you could hear it, it would be the loudest sound in existence, a note struck by the death of a sun. The outer layers rebound, creating a shockwave. As the core collapses inward, it hits a wall of incompressibility, neutrons packed so tightly that they resist further contraction. The infalling matter rebounds violently. A shockwave forms and races outward through the star's layers. What follows is an eruption beyond imagination, an outward surge of light, heat, and energy that tears the star apart from within. It is both destruction and liberation, a single moment where the universe converts despair into brilliance. Temperatures exceed 1 billion degrees. In the core of a supernova, heat surpasses 1 billion degrees Kelvin, a temperature so extreme that matter itself begins to unravel. Nuclei shatter and reform. New combinations of particles emerge. Under these conditions, even heavy elements that never formed during the star's lifetime are born in an instant. This heat, though short-lived, is the forge of cosmic chemistry, the final heartbeat of creation before silence returns. In moments, new elements are forged. Rapid nucleosynthesis. This final act is called rapid nucleosynthesis, a frenzy of atomic construction that happens in seconds. Neutrons flood atomic nuclei faster than they can decay, forming exotic, heavy elements. The universe, which once held only hydrogen and helium, now bursts into diversity. Dozens of new elements are created at once: cobalt, nickel, silver, gold. Uranium, the rarest and most precious matter known. Each born from chaos. Each destined to wander the galaxy as stardust. This is the R process, rapid neutron capture. The R process is one of the most astonishing mechanisms in all of physics. In the dense neutron storm of a supernova, atomic nuclei capture neutrons so quickly that new isotopes form in rapid succession. These isotopes then decay into stable heavy elements. It's nature's way of pushing matter to its limits, creating complexity where there was once only simplicity. In mere seconds, the universe expands its periodic table. Heavy elements like gold and platinum form here. The glittering metals we treasure, gold, platinum, palladium, do not form in calm conditions. They require cosmic violence. In the furnace of a collapsing star, these atoms come to life. Each gold atom in your ring, each platinum trace in your blood, once swam in a supernova's blinding storm. That quiet shine you see on Earth is the cooled memory of an explosion so powerful it reshaped the galaxy. A teaspoon of supernova core could weigh billions of tons. After the collapse, the stellar core becomes so dense that its matter defies comprehension. A teaspoon of it would weigh billions of tons, more than all the mountains on Earth combined. Inside, atoms no longer exist as we know them. Instead, there's a degenerate sea of neutrons, packed tightly enough to bend space-time itself. This remnant is a neutron star, one of the most extreme objects in the universe, spinning at hundreds of times per second, glowing faintly in the dark like a cosmic ember. The blast lights up an entire galaxy. When a supernova erupts, for a brief time it can outshine everything around it. One dying star radiates more energy than 100 billion suns. From millions of light years away, its flare can still be seen by telescopes, a sudden, brilliant bloom in the blackness. It's as if the universe blinks, and when it opens its eyes again, a new chemistry has been born. The brightness fades, but what remains changes everything. Dust from the explosion seeds new stars. After the explosion, the star's outer layers drift outward, cooling into fine grains of cosmic dust. This dust becomes the raw material for the next generation of stars. The cycle begins again: collapse, birth, fusion, death, renewal. Each generation inherits the ashes of the last. The very clouds that will one day form new solar systems are thick with remnants of ancient fire. The night sky is a nursery of ghosts, becoming light once more. Those clouds carry memory, chemistry of the old universe. Each molecule, each atom, carries history within it. The dust of a supernova is not random, it is patterned, marked by its origin. Scientists can read this chemical memory through light, decoding the fingerprints of the stars that came before. Every cloud of gas we observe in space is a library of the past. Each spectral line a page written in starlight. Neutron stars are the remains of the densest cores. If the collapsing core of a supernova doesn't become a black hole, it stabilizes as a neutron star, an object so compact that a mountain on its surface would weigh more than the Himalayas combined. These stars are tiny, barely 20 kilometers wide, yet they spin with astonishing speed, sometimes hundreds of times per second. Their magnetic fields are trillions of times stronger than Earth's. Some pulse regularly, sending out rhythmic beacons of radiation, pulsars, the ticking clocks of the cosmos. Some supernovae leave black holes instead. When the star's core is even more massive, gravity wins completely. The collapse continues past the point of resistance, crushing all matter into a singularity, a region of infinite density. A black hole is born. It does not shine, but it influences everything around it. Even light cannot escape its grasp. Yet, paradoxically, it gives shape to galaxies, anchoring their swirling arms. In its silence, it governs. In its darkness, it sculpts. Even black holes may help create heavy elements through jets. Though black holes consume, they also give. When matter spirals into their accretion disks, intense magnetic fields can hurl jets of plasma into space at nearly the speed of light. These jets are not empty. They carry newly forged nuclei, created under immense pressure and radiation. Some of the universe's heaviest elements, gold, platinum, thorium, may owe their existence to these black hole forges. From the abyss comes abundance. The universe's gold comes from such depths. Every piece of gold you've ever seen, every coin, every ring, every flake of dust, was created in death. It was born when a star collapsed, or when two neutron stars collided, releasing energy beyond human comprehension. Each atom of gold has traveled through fire, vacuum, and time to reach you. When you wear gold, you carry the story of a sun that once died so another world could form. Your blood's iron was born in an exploding sun. Iron is essential to life. It carries oxygen through. Your blood gives color to vitality itself. Yet its origin is celestial. It was forged in the heart of a supernova, spread across space, and eventually gathered into Earth. Every heartbeat you feel is powered by the same element that once glowed red in a dying star's final breath. You are, quite literally, animated stardust. You are literally made of stellar remains. Your bones, your skin, your breath, all assembled from matter once inside stars. The calcium in your teeth, the carbon in your cells, the oxygen in your lungs, none of them began here. They were created billions of years ago in ancient stars that lived, burned, and died long before our sun was born. You are a continuation of their story, a chapter in the autobiography of the cosmos. Every supernova is both an ending and a beginning. To the universe, there is no true tragedy in the death of a star. Each explosion clears space for new birth, scattering the ingredients that will form future suns and planets. The shockwave compresses nearby gas clouds, triggering new rounds of star formation. Death becomes the architect of life. The rhythm is eternal: collapse, explosion, renewal, a cosmic heartbeat that echoes through every galaxy. Its echo travels across millions of years. Light from a supernova travels vast distances, carrying the story of its origin. By the time it reaches us, millions of years may have passed. Some of the light captured by our telescopes tonight began its journey when early humans were just learning to speak. To watch the stars is to look backward through time, to witness events that have long since ended, yet continue to shine. Some of the light we see tonight left its star before humans existed. When you gaze at the stars, you are seeing the past. The light of distant suns may have started its journey before the Earth even had life. Some beams have traveled for millions, even billions of years, crossing expanding space to reach your eyes. You are witnessing ancient history written in photons. The universe speaks, softly and slowly, through the language of light. The night sky is filled with ancestral fire. Every point of light above you is a memorial and a promise, the glow of a star that once lived, the echo of energy still wandering through the dark. You stand beneath a sky made of memories, the atoms in your body, the warmth in your chest, the thoughts in your mind, all descended from those fires. The night sky is not empty. It is filled with family. Nucleosynthesis means the making of new nuclei. At its heart, the universe is a craftsman. Nucleosynthesis is its art, the quiet act of building new atomic nuclei from smaller ones. It happens wherever temperature and pressure conspire to bring particles close enough to merge. In the first moments after the Big Bang, it gave us hydrogen and helium. In the hearts of stars, it gave us carbon, oxygen, and iron. In the furious seconds of supernovae, it gave us gold and uranium. Every element in existence is a chapter in this ongoing process. The cosmos is always building, one nucleus at a time, one heartbeat of fusion after another, endlessly refining its masterpiece. There are slow and rapid versions, S process and R process. Nature doesn't create everything at once. Sometimes it prefers patience, a slow crafting that unfolds over millions of years. Other times, it chooses speed and violence. These two rhythms define nucleosynthesis. The slow neutron capture process, or S process, happens in calm stars nearing the end of their lives. The rapid neutron capture process, or R process, happens in explosions and collisions, a storm of creation. Between them, the universe finds balance, one gentle, one fierce, together forming the full orchestra of matter. The S process happens in aging red giants, in the swollen atmospheres of dying stars, where helium burns gently in deep layers, neutrons drift through space like soft rain. Occasionally, one is captured by an atomic nucleus. Slowly, element by element, heavier atoms form: strontium, barium, lead. The process is delicate, steady, almost peaceful. Each reaction adds just one neutron at a time, as if the universe were writing a symphony note by note. When the star's outer layers drift away, these S-process elements enrich the galaxy. Carried on winds of glowing dust, it slowly builds heavier atoms by neutron capture. Neutron capture is the simplest gesture of creation. A nucleus catches a free neutron, neutral, gentle, silent, and grows slightly heavier. Over time, this slow addition transforms simple atoms into complex ones. It's like the slow layering of color in a cosmic painting. In red giants, this happens in steady rhythm over thousands of years. There is no explosion, no roar, only time, patience, and the quiet gravity of chemistry in motion. The R process happens in supernovae or neutron star mergers. Then there is the opposite, creation by chaos. When massive stars explode, or when two neutron stars collide, torrents of neutrons flood space. Atomic nuclei are bombarded faster than they can decay, building heavy, unstable isotopes that soon settle into precious metals. This is the R process, the universe's most intense burst of creativity. In a fraction of a second, The cosmos creates more variety than in millions of years of peaceful fusion. It's the cosmic version of lightning striking, brief, blinding, but eternally transformative. There, atoms grow in sudden bursts. In those moments of unimaginable density, atomic seeds swell rapidly, capturing neutron after neutron until they cannot hold more. When the storm passes, they stabilize, becoming the heavy elements that shape worlds and civilizations. The suddenness is breathtaking. Matter that didn't exist before now fills the universe. Every gold atom, every bit of platinum dust, was born in a single heartbeat of this process. Creation condensed into an instant, and yet its products will last forever. Between these two, almost every element is born. The slow S process and the fast R process are like the inhale and exhale of creation. Together, they fill the periodic table with life. From sodium to tin, from copper to uranium, every atom in existence owes its birth to one of these cosmic rhythms. The stars are like workshops, each with their own tempo, some weaving slowly in silence, others erupting in brilliance. Between them, the universe composes itself. Each isotope tells a story of its birthplace. Every atom is unique, but isotopes carry even deeper secrets. They are the fingerprints of where and how that atom was made. Some isotopes are born in calm interiors of red giants, others in the explosive breath of supernovae. Scientists can trace these origins by studying ratios of isotopes in meteorites or starlight. In this way, we can read the biography of matter, an autobiography written in the language of atomic decay. Each isotope whispers, "I was born in fire." Scientists read that story by studying starlight. Light carries memory. When it passes through gas, it absorbs certain colors, wavelengths, leaving dark lines in its spectrum. These lines are clues, telling us what elements lie within the star. By analyzing starlight, scientists can determine not only what a star is made of, but also how old it is, and even what kind of processes happened inside it. Every photon becomes a messenger, carrying chemical gossip across light years. Every element leaves a spectral fingerprint. Each element interacts with light in its own way, absorbing or emitting specific wavelengths. The result is a distinct pattern, a spectral fingerprint that no other element shares. Hydrogen's lines are bright and clean. Sodium's glow is deep orange. Oxygen leaves green traces in the fog of nebulae. These spectral signatures are the universe's language, its method of self-expression. When astronomers read them, they are, in a sense, listening to stars speak. That fingerprint reveals what stars are made of. By comparing these spectral lines, scientists can reconstruct a star's entire composition. They can tell which stars are young and which are old, which have lived through multiple generations of cosmic recycling, and which are still pure. The light we see is not random, it's coded. Each wavelength is a data point, a word, a phrase in the universe's ongoing conversation about itself. Astronomy is chemistry at a cosmic scale. We often think of chemistry as something that happens in test tubes or laboratories. But in truth, every reaction, every bond, every molecule is a miniature version of what happens among the stars. The difference is only scale. Where we use burners and glassware, the cosmos uses galaxies and time. The same equations apply. The same dance of attraction and transformation. The universe is one vast laboratory, and we, by observing it, are both its experiment and its witnesses. Hydrogen lines are bright and simple. Hydrogen, the first and most abundant element, leaves its mark clearly in the spectrum. Crisp, unambiguous, beautiful. Its Balmer lines paint the visible spectrum with shades of violet and red, traces that appear in almost every star we observe. These lines are like the universe's signature, a reminder of its humble beginnings. No matter how complex things become, hydrogen's simplicity, endures, woven through every pattern of light. Oxygen glows green in nebulae. In the dark depths of nebulae, oxygen atoms glow with an eerie green when excited by ultraviolet light from nearby stars. It's a soft, ghostly color, the hue of life's essential breath echoing across light years. Through telescopes, we see this glow in clouds like the Orion Nebula, where new stars are born. Oxygen is not just an element. It is illumination, both literal and symbolic, breathing color into the universe. Iron lines shimmer in supernova remnants. After a star's death, the surrounding nebula glows with the traces of its last act. Among the most striking signatures are the iron emission lines. Thin, bright, intricate. Iron is the element of balance, the bridge between creation and collapse. When scientists see its spectral lines, they are seeing the moment where a star stopped giving energy and began returning its matter. Iron's shimmer is the final note in the song of a star's life. Lithium's faint trace marks the early universe. Lithium is rare, fragile, and ancient. Its abundance tells cosmologists about the first few minutes after the Big Bang, when it was forged in small amounts before stars ever existed. Later, much of it was destroyed in stellar interiors. What remains is a faint echo, detectable in certain old stars and interstellar gas clouds. It's the universe's subtle whisper, a reminder of its infancy, like a baby's footprint left in stone. Through spectra, we decode the past. Each beam of light is a time capsule. When it reaches us, it carries information from eons ago. By spreading that light into its component wavelengths, a spectrum, we can reconstruct the conditions of its origin. It's like opening a letter sent from the beginning of time. The stars are historians, and light is their ink. To read it is to remember, not in words, but in wavelengths. The elements are the universe speaking in light. If the cosmos has a language, it is written in photons. Every color, every line, every glow tells a story of fusion, decay, or transformation. To the naked eye, the sky is full of stars. To science, it is full of sentences. Together, they describe how the universe became aware of itself, through chemistry, through energy, through endless conversation across the void. Every color in the sky is an equation, fulfilled. When you look at the deep blues of space, the reds of distant galaxies, the pinks and greens of nebulae, you are seeing mathematics made visible. Each hue represents a transition, an electron falling, a photon released, an equation solved perfectly. The universe doesn't just exist. It performs, harmonizing physics and beauty in equal measure. Every color is a calculation, completed in silence. Alchemy, at last, became science. Long ago, humans dreamed of turning lead into gold. They didn't yet know that nature had already mastered that art. In stars, in explosions, in the steady work of fusion. The ancient word alchemy meant transformation, and in the cosmic sense, it's true. The universe is an alchemist. But now we understand its formulas, its fire, its patience. The magic remains. Only now we can see the mathematics beneath the wonder. The periodic table is a reflection of the stars. Look at the periodic table, and you are looking at a portrait of the cosmos. Every box, every symbol, is a memory of stellar fire. Hydrogen and helium from the Big Bang, carbon and oxygen from red giants, gold and uranium from dying suns. What chemists see as a chart, the universe sees as its autobiography, each element a sentence in its endless poem. From simplicity came order, from order came diversity. The periodic table is not just a list of substances. It is the universe remembering what it can become. Hydrogen is cosmic origin. Hydrogen, one proton, one electron. The simplest, most ancient, and most abundant element. It is the first letter in the alphabet of existence. Every star burns it, Every planet began with it. In your body, hydrogen binds with oxygen to form water, the essence of life. It is the thread that ties together oceans, clouds, and stars. When you drink, when you breathe, you continue a ritual that began billions of years ago in the universe's first moments. Helium, the laughter of fusion. Helium, light and graceful, is the product of joy in stars, the laughter of hydrogen as it transforms. It is inert, peaceful, untouchable, refusing to bond with others. In our world, it lifts balloons and voices. In the cosmos, it lifts darkness into light. Born from fusion, it reminds us that creation can be gentle, that not all power is violence. Some is grace, quiet and enduring. Carbon, the skeleton of life. Carbon is the architect of living matter. Its unique ability to bond in long, complex chains makes it the foundation of organic chemistry. Every cell, every leaf, every thought depends on its flexibility. Carbon connects hydrogen, oxygen, nitrogen, weaving molecules of memory and emotion. Yet carbon is also born in stars, created from helium in the hearts of giants. It carries both the signature of fire and the promise of life. The same carbon that builds a mountain can form the backbone of your DNA. Oxygen, the breath of worlds. Oxygen is the element of exchange, the great connector between energy and existence. It allows fire to burn, lungs to breathe, stars to glow. In space, it combines with hydrogen to form water, sculpting oceans and clouds. Its spectral glow paints nebulae green and blue, the hues of rebirth. Each breath you take is a conversation with the stars. You inhale what they exhaled long ago. Nitrogen, the quiet element of DNA. Nitrogen does not announce itself with color or heat. It works in silence, building proteins, stabilizing genetic codes, binding the very instructions of life. It is 78% of the air you breathe, invisible yet essential. Within your body, nitrogen atoms link strands of DNA, holding together the blueprint of being. In the cosmic sense, it is the poet of the elements, subtle, calm, and infinitely patient. Iron, the heart of planets and blood. Iron is where creation and collapse meet. It marks the boundary between energy gained and energy lost in fusion. When stars forge iron, they prepare to die, yet that death gives life to others. On Earth, iron forms the planet's molten core, generating the magnetic field that shields us from cosmic radiation. In your body, it carries oxygen through blood, turning it red, the color of vitality. Iron is the pulse of both earth and heart, the rhythm shared by planets and people alike. Gold, a relic of cataclysm. Gold's luster is born from chaos. It was not made in the calm of stars, but in their violent deaths, the R process of supernovae and neutron star collisions. Every glittering grain was forged in a moment of unimaginable force. Its beauty lies in survival. From destruction came permanence. Humanity prizes gold for its incorruptibility, but the cosmos prizes it for memory, each atom a record of an explosion that reshaped the galaxy. Uranium, the echo of ancient explosions. At the far end of the periodic table lies uranium, heavy, unstable, ancient. It is a remnant of cosmic violence, the last note of a dying star's song. Within it still lies the potential for more fire. When split, it releases energy, once trapped in stellar cores. In this way, uranium connects past and present, the energy of stars reborn in human hands. It is both a warning and a wonder. The universe entrusted us with its final spark. Silicon, the backbone of rock and technology. Silicon bridges two worlds, geological and digital. It is the skeleton of minerals and the heart of machines. Found in sand and quartz, it forms mountains, glass, and the circuits of your computer. When combined with oxygen, it shapes the crusts of planets. When refined, it shapes the logic of civilization. Silicon reminds us that the Earth itself participates in the act of thought, that intelligence may one day spread beyond biology, built upon the same atoms that form stone. Calcium, the mineral of life and stone. Calcium lives in two realms, the bones of creatures and the skeletons of worlds. It builds coral reefs, mountain ranges, and the frameworks of bodies. Each heartbeat relies on calcium ions to signal contraction, the rhythm of life itself. In the stars, it forms from carbon and oxygen fusion. When you see chalk cliffs or marble statues, you are seeing the remains of ancient life made permanent. Calcium is the meeting point between biology and geology, between pulse and permanence. Each element finds purpose in balance. No element exists alone. Hydrogen finds helium, oxygen seeks carbon. Iron stabilizes planets, nitrogen supports life. The universe is an intricate dance of attraction and equilibrium. Too much of one, and systems collapse. Too little, and creation halts. From this balance, everything arises: stars, worlds, consciousness. Chemistry, at its core, is not just reaction, it is relationship. The periodic table is not random, it's evolutionary. Each element builds upon the last. Hydrogen gives rise to helium, helium to carbon, carbon to oxygen, and so on, a ladder of increasing complexity. The table's structure mirrors this evolution. From simple to complex, from stability to decay. It's a map of time, a chart of creation itself. The elements evolve not through biology, but through physics, each one the child of a star older than imagination. From hydrogen to organocene, the story continues. Even now, the table expands. Scientists have created new elements that exist for mere fractions of a second. Organocene, element 118. A ghost that flickers and vanishes. Yet even these ephemeral atoms prove that creation hasn't ended. The universe continues to experiment, to extend its vocabulary. There may be elements yet to be discovered, or entire branches of matter we cannot yet conceive. The story of chemistry is still being written. Some elements are natural, others made by us. Humans, too, have become creators of matter. By smashing nuclei together in accelerators, we forge new elements, synthetic, short-lived, but real. For the first time, intelligence participates in the cosmic act of nucleosynthesis. We are not separate from the stars. We are their heirs, continuing their work on smaller scales. Each discovery adds another note to the cosmic symphony of matter. In particle accelerators, we mimic the stars. Inside massive rings of magnets, protons race near the speed of light, colliding with unimaginable force. In those collisions, temperatures and pressures rival those of stellar cores. For an instant, the lab becomes a star, recreating the birth of elements that nature once formed only in supernovae. The universe, through us, observes itself repeating its oldest miracles. Science is not imitation, it is participation. Humanity has become part of the cosmic forge. With our machines, our equations, and our curiosity, we have joined the same process that began in the first stars. When we split atoms or fuse them, we tap into the same forces that shape the galaxies. We are, in essence, small-scale stars, luminous minds made from the dust of the universe, now learning to ignite creation consciously. The forge no longer belongs only to the heavens. It burns quietly in laboratories, in minds, in dreams. Every lab experiment echoes a star's core. Each spark in a reactor, each particle collision, each reaction flask glowing in a scientist's hand. All of them mirror the physics of the cosmos. The difference is scale, not essence. The energy released, the bonds formed, the transformations observed, They are the same processes that built planets and suns. Every discovery is the universe recognizing itself through the hands of its own creation. The table of elements is a prayer in scientific form. When you look at the periodic table, the clean lines, the order, the structure, it feels almost sacred. It is humanity's version of a cosmic mandala, a visual hymn to pattern and logic. Each element sits in its rightful place, bound by invisible rules that mirror the symmetry of nature. It is both map and mantra, reminding us that understanding the universe is a form of reverence. We are the readers of its sacred order. The universe wrote its story in elements. We learn to read it. From the hydrogen of dawn to the uranium of endings, we trace its letters across the stars. The periodic table is not a human invention. It is a human translation of a universal truth. To study it is to listen to the stars, speak their alphabet aloud. And when we do, we realize we are not outsiders looking in. We are part of the same sentence, written in light. When stars die, their dust forms planets. After the great deaths of stars, their ashes drift through space. Carbon, iron, silicon, oxygen, all suspended in silence. Gravity gathers them once more into new clouds, new suns, new worlds. Every planet begins as dust, cooled fragments of cosmic memory pressed together over eons. What seems solid beneath your feet is the final form of that dust, made dense by time. The stones you walk upon were once gas, glowing and free. The earth itself is a sculpture molded from the breath of stars long gone. The heavier elements sink toward their cores. When a planet forms, its molten body sorts itself like a living cell. Heavy metals such as iron and nickel sink to the center, while lighter elements rise outward. This quiet sorting, called differentiation, is what gives planets their layers, core, mantle, crust. It is a cosmic act of organization, a gravitational heartbeat still echoing through Earth's history. The heavy elements that once blazed in stars now rest deep below, holding the planet together from within. Lighter ones float to form atmospheres. Not all elements stay locked in stone. The lighter gases, hydrogen, oxygen, nitrogen, drift upward, forming a veil of air. The atmosphere becomes the planet's breath, exchanging particles with space, protecting its surface from radiation, nurturing clouds and weather. This airy layer is both shield and mirror, a thin skin separating life from the void, yet connected to the same cosmic chemistry that shaped it. Earth's iron core keeps our magnetic field alive. Deep beneath our feet, molten iron swirls like a slow ocean of fire. Its motion generates electric currents, which in turn create Earth's magnetic field, an invisible cocoon deflecting cosmic rays and solar winds. Without it, the atmosphere would vanish, stripped away like dust. The compass, the aurora, even our sense of direction, all owe their existence to that churning iron heart. The planet is alive in more ways than one. Silicates form. Mountains, sand, and glass. Silicon and oxygen combine to create silicates, the most common family of minerals in Earth's crust. From these, mountains rise, deserts spread, and beaches shimmer. When melted and cooled, silicates become glass, nature's transparent memory. Every grain of sand on a shore is a fragment of this chemistry, born of pressure, refined by time, sculpted by wind and water. When you hold a handful of sand, you hold the language of the planet, billions of tiny syllables written by stone. Carbon mixes into life and stone alike. Carbon is a wanderer. It lives both in living creatures and in the lifeless stone beneath them. It forms shells, bones, diamonds, and leaves. When buried, it becomes coal. When released, it joins the air as carbon dioxide. Its endless circulation between rock, air, and life is called the carbon cycle, a planetary heartbeat measured not in seconds, but in millennia. Every carbon atom in your body has likely been a mountain, an ocean wave, and a breath before. Oxygen binds with everything, the great connector. Oxygen loves to join. It bonds with hydrogen to make water, with silicon to make rock, with carbon to make life. Its eagerness for connection drives nearly all chemistry on Earth. When it burns, it gives light. When it flows, it gives breath. It is the invisible thread that links the biosphere to the geosphere, the sky to the sea. Without oxygen's generosity, the world would be silent. No flame, no rust, no life. Gold and platinum sank deep underground long ago. When Earth was still molten, dense metals like gold, platinum, and iridium sank toward its center, drawn by gravity's relentless pull. Only a few survived near the surface, delivered by later asteroid impacts. The veins of gold mined today are cosmic relics, fragments of what the planet once hid away. Each nugget gleaming under sunlight is a survivor from Earth's fiery youth. A reminder that beauty often sleeps beneath pressure. The ocean's salt is the planet's ancient memory. Every grain of salt in the sea carries a trace of Earth's past, eroded rock, volcanic gas, mineral dust dissolved over eons. The ocean is not just water. It's a vast solution of the planet itself. Sodium and chlorine, calcium and magnesium, the same elements that flow in your blood also circulate in waves. When you taste the sea, you taste your own origins. Salt is the flavor of memory. Volcanoes release the breath of chemistry. Volcanoes are the planet's exhalations. From deep within, gases and minerals rise through molten rock, bursting into the open air. Each eruption releases carbon dioxide, sulfur, and water vapor, materials that shape climates, form soils, and feed life. Though destructive, volcanoes renew the earth, recycling elements between its inner and outer layers. Their fire reminds us that beneath calm soil lies ceaseless movement, the same restless energy that once built stars. Lightning forges nitrogen compounds. When lightning tears through the sky, it splits nitrogen molecules apart, allowing them to bind with oxygen and form nitrates. These compounds fall with rain, nourishing the soil. Without them, plants could not grow. The flash of a storm is more than spectacle. It is chemistry in action, a bridge between sky and life. Each bolt carries the same creative spark that began in stars, returning to Earth as food and fertility. Life feeds on the balance of carbon, hydrogen, nitrogen, oxygen. Four elements dominate all biology: carbon, hydrogen, nitrogen, and oxygen. Together, they form proteins, sugars, and DNA. Their balance sustains every breath, every heartbeat. Too much of one, and ecosystems falter. Too little, and life fades. This harmony, known as Chan, is the alphabet of existence. From bacteria to humans, every living thing writes its story using these same 4 letters, rearranged endlessly but always legible to nature. These 4, Chan, are the alphabet of biology. In every cell, these letters combine in countless patterns. Carbon chains for structure, hydrogen for flexibility, oxygen for energy, nitrogen for growth. They form molecules that remember, repair, and reproduce. DNA is not magic. It is chemistry fluent in the language of stars. Life is simply the universe learning to spell itself. Every cell is a miniature periodic table. Within each living cell exists a perfect reflection of cosmic order. Dozens of elements: sodium, potassium, phosphorus, iron, zinc, perform their ancient roles, orchestrated in harmony. They exchange charges, carry signals, and transfer energy, just as they did in the hearts of stars. A cell is not an isolated thing. It's a small-scale cosmos, humming quietly with atomic music. The Earth's crust whispers its stellar ancestry. Look closely at rock, and you'll see a record of its cosmic birth. Iron from ancient stars, silicon from supernovae, carbon from the ashes of giants. Each mineral crystal is a time capsule, a fossil of energy once free. When geologists study strata, they are reading chapters written before the Earth existed. Even in silence, the crust speaks, in the slow language of pressure, temperature, and time. Even the moon carries metallic scars of old impacts. The moon's surface is pocked with craters, each one a relic of violence. Many of those impacts brought metals from the early solar system: iron, titanium, nickel. The moon reflects sunlight, but it also reflects history. The scars of creation still visible in its pale skin. When you look up at it, you see the memory of collisions that helped build us all. Mars's red dust is iron oxide, rust from another sun. Mars glows red because its surface is covered in iron oxide, the same compound that forms rust on Earth. Billions of years ago, Mars once had water, air, and volcanic fire. Its iron reacted with oxygen, staining the planet crimson. The red we see now is the residue of lost vitality, the planet's way of remembering its own atmosphere. Even in desolation, it remains beautiful. Venus glows with sulfuric clouds. Venus is Earth's twin in size, but opposite in fate. Its thick clouds are made of sulfuric acid, born from volcanic outgassing and trapped by an unforgiving greenhouse effect. Beneath that toxic veil, the surface burns at over 400 degrees Celsius, hot enough to melt lead. Yet those clouds, illuminated by sunlight, shimmer with golden light. Even ruin can glow. Venus teaches that chemistry, like destiny, can turn on a single imbalance. Mercury is dense with iron, forged close to fire. Closest to the sun, Mercury bears the scars of its proximity. Most of its lighter materials were stripped away long ago, leaving a dense iron core wrapped in a thin shell of rock. Its surface is scorched and silent, yet its metallic heart still spins, generating a faint magnetic field. Mercury is a reminder that even the smallest worlds hold great strength, forged not by chance, but by endurance. The planets are the stars' chemical children. From Mercury's iron to Earth's oceans, from Mars's rust to Jupiter's storms, every planet is a continuation of stellar chemistry. The elements that once danced in a furnace now sleep in stone, swirl in clouds, or flow in rivers. The solar system is a family portrait painted in elements, each world carrying the signature of the stars that came before. The planets are not separate from the cosmos. They are its echoes, cooled into form. Life's chemistry began in stardust. Before life had form or color, the ingredients were already waiting, drifting through interstellar clouds as dust, molecules, and ice. Carbon, hydrogen, nitrogen, and oxygen wandered the cosmos, seeking structure. Then, in the cold vacuum of space, they began to combine, forming amino acids, simple sugars, and organic molecules. These weren't yet alive, but they carried the pattern of life, the potential to replicate, to remember, to evolve. When this stardust eventually found its way to young planets, like Earth, it brought not just material, but possibility, the dream of chemistry becoming biology. Amino acids formed on ancient asteroids, billions of years ago, as the solar system was still forming. Asteroids and comets became laboratories of creation. Inside their icy interiors, cosmic radiation and simple molecules, methane, ammonia, water, reacted to form amino acids, the building blocks of proteins. When these rocks later collided with Earth, they seeded its oceans with the precursors of life. Even now, scientists find these same amino acids in meteorites, proof that the recipe for life is written across the universe, not unique to us, but part of a cosmic tradition. Meteorites carried them to young planets. The early Earth was chaotic, molten, storm-filled, alive with lightning. Into that fiery world fell countless meteorites, each carrying the chemistry of the stars. When they hit the oceans, they dissolved, releasing organic molecules into the primordial waters. In those shallow seas, molecules met, collided, joined, and copied themselves. The universe had thrown its seeds across space, and here they took root. Life did not begin on Earth alone. It began everywhere matter could dream. Carbon bonds made the first molecules of memory. Carbon is the element of connection. Its 4 arms can bond in almost infinite ways, forming chains, rings, and branches, the architecture of complexity. In the ancient oceans, carbon's flexibility gave birth to the first self-replicating molecules. These were the prototypes of RNA and DNA, the molecules that would one day remember and repeat. In a sense, memory itself was born from carbon's willingness to connect. Through these bonds, the universe began to record itself, to tell its own story through matter. Hydrogen gave water, the solvent of life. Hydrogen, the universe's first element, met oxygen, a later creation of stars, and together they formed water. Simple, yet miraculous. Water became the stage for life's earliest experiments. It dissolves, mixes, protects. It carries heat and memory. It can hold and release, freeze and flow. Every organism on Earth is shaped by water's generosity. In every drop, hydrogen whispers of the Big Bang, and oxygen of dying stars, their union, the cradle of existence. Oxygen made respiration possible. Billions of years later, oxygen filled the sky, released by the first photosynthetic bacteria. For the first time, life could breathe, could use oxygen's hunger for electrons to extract energy from food. This was the moment of awakening. Respiration, metabolism, movement. Oxygen made it possible for life to grow larger, more complex, more aware. The same element that lights stars now fuels every living cell. When you inhale, you continue that same transaction, a gift passed down through cosmic generations. Iron carried oxygen in blood. Iron, forged in ancient supernovae, became the heart of life's most vital exchange. In your blood, it binds with oxygen, carrying it through your body in hemoglobin molecules. With each breath, iron repeats its stellar role, balancing energy, moving light within flesh. The red color of blood is the color of iron oxidizing, the same chemistry that turns Mars red and Earth's rocks rusty. Every heartbeat is a quiet echo of a star's pulse. Long ago, phosphorus built DNA's backbone. Without phosphorus, life's language could not be written. It forms the structural spine of DNA and RNA, linking one base to the next, one generation to another. Phosphorus also powers cells through ADP, the molecule that stores energy. It is both architecture and electricity, a bridge between structure and motion. Traces of phosphorus were once scattered in cosmic dust. Now they form the foundation of thought, memory, and evolution. Calcium shaped bones and shells. Calcium, light, strong, and abundant, became life's choice for stability. It hardens bones, forms coral reefs, builds the armor of shellfish. Yet it's also fluid, carried in blood, signaling muscles to move and hearts to beat. Every structure, every motion relies on it. When you stand upright, when you breathe, when you speak, calcium is at work, a piece of ancient starlight holding you together. Sodium and potassium spark neural fire. Your thoughts are electric. Every signal in your brain, every movement in your body, depends on the delicate balance between sodium and potassium ions crossing membranes. This exchange creates voltage, a pulse of energy that races through your nervous system at incredible speed. These elements, once drifting in seas and space, now create the lightning of consciousness. A neuron firing is a storm contained, a small echo of the thunder that once forged nitrogen in the sky. Even trace elements, zinc, copper, were gifts of stars, though present only in small amounts. Trace elements shape everything. Zinc helps enzymes fold proteins. Copper carries electrons in cells. Selenium shields DNA from damage. Each one plays a subtle, essential role, the fine-tuned harmony of life. They are the universe's delicate touches, proof that complexity doesn't come from abundance, but from balance. In your body, the rarest atoms perform the most elegant tasks. Your body holds more than 60 different elements. From hydrogen to iron, from calcium to iodine, your body is a mosaic of the cosmos. Some atoms in you are older than the sun. Others were forged in nearby stars. Every second, countless reactions occur, rearranging, renewing, sustaining. You are not a single thing, but a constantly changing constellation of matter. Life is not about possessing atoms. It is about the rhythm of their exchange. Each has a cosmic birthplace. Every element inside you has a home among the stars. Hydrogen, the Big Bang. Carbon, red giants. Iron, supernovae. Phosphorus, the debris of dying suns. You are a map of stellar geography, a living record of cosmic history. Your body is not separate from the universe. It is one small part of its ongoing evolution. When you close your eyes and feel your heartbeat, you are hearing the echo of creation itself. You are the universe become self-aware. At some point, in one corner of a galaxy, matter began to think. Atoms that once burned in stars arranged themselves into neurons capable of reflection. The universe looked back at itself and whispered, "I am." Consciousness is not an accident. It is the cosmos experiencing its own beauty. Through you, the stars contemplate their origins. Through your eyes, the universe observes its own unfolding. When you breathe, you recycle starlight. The air entering your lungs has been everywhere, through trees, oceans, volcanoes, and stars. Every inhale pulls in oxygen once bound in rocks, once burned in stars, once part of another creature. Every exhale releases carbon that will one day feed another life. Breathing is not just biological, it is cosmic recycling, the endless circulation of light and matter through form after form. When you speak, you vibrate atoms once inside suns. Your voice is made of air, vibration, and intent, all carried on molecules born in fire. When you speak, your breath turns stardust into sound. Each word you say ripples through space as a pattern of pressure, fading but never fully disappearing. Somewhere, perhaps, those vibrations join the cosmic background, merging with the echoes of the Big Bang. Even in speech, you are part of the ongoing conversation of the universe. When you sleep, the cosmos rests through you. At night, as you drift into stillness, your body returns to its natural rhythm, slow, quiet, expansive. Every cell continues its chemistry, softly exchanging atoms, releasing energy. You become the universe. At peace, a small reflection of its calm between cycles of fire and birth. The stars burn far away, but their light glows gently behind your eyelids. Sleep is not escape, it is reunion. Chemistry became consciousness. There was a time when matter only reacted, when atoms met and parted without awareness. But through time and complexity, reactions turned into recognition. Molecules learned to sense, to adapt, to remember. Eventually, matter began to imagine, to wonder what it was made of. That is what you are. Chemistry that learned to ask questions about itself. The laws of physics turned inward and found meaning. The elements learned to dream. In you, in all living beings, the elements do more than exist, they imagine. They build stories, emotions, songs. Carbon and calcium, hydrogen and nitrogen. Together they weave art, hope, and longing. The same atoms that once drifted through void now love, remember, and mourn. The elements, it seems, have always been reaching for awareness, and in life, they found their reflection. And here we are, the dreaming dust. From the silence of the void, to the fire of stars, to the breath of creatures, the journey of matter has always moved toward complexity, toward thought. You are that culmination, a brief, shining form made of ancient atoms, now capable of dreaming of their own origins. When you look at the night sky, you are seeing yourself in another form. The universe dreamed, and the dream became you. Stars die, their matter returns to space. No star shines forever. When their fuel is spent, they collapse, erupt, or fade, returning their elements to the vast interstellar sea. Carbon, oxygen, iron, silicon, all released, drifting once more through space. Their light ends, but their matter continues. The death of a star is never an ending, only a redistribution. The universe does not waste. It reclaims, recycles, begins again. Each sunset in the cosmos is a sunrise waiting to happen somewhere else. Clouds form again from their ashes. Out in the galactic night, the remnants of dead stars mingle. Gas and dust gather slowly, drawn together by gravity's patience. These clouds, nebulae, glow faintly from starlight passing through them, beautiful and fragile. They are the wombs of new creation. Within them, new stars are quietly assembling. From the ashes of the old, the universe breathes in, collecting its scattered self, preparing for another heartbeat. New stars ignite from the same dust. Within those clouds, small knots of matter grow dense and hot. Pressure rises, fusion begins, and suddenly a new light flickers into existence. Each new star carries within it the chemistry of its ancestors, enriched by the metals, minerals, and molecules left behind. A second generation begins to shine. The story continues. What once died now burns again, reshaped, but recognizable. The dust remembers how to glow. Every generation enriches the next. The first stars created helium and carbon. Their deaths produced iron and gold. The next generation inherited that richness, crafting even more complex worlds. By the time our sun was born, the galaxy had been through billions of such cycles, enough to fill planets with diversity, enough to make life possible. Each round of creation deepens the universe's palette, adding shades of color and possibility. We are born not from the first light, but from its countless reflections. Galaxies evolve chemically over time. A young galaxy is poor, simple, bright, and raw. As stars live and die within it, heavier elements accumulate. The gas between stars grows richer. The planets that form become more intricate. In this way, galaxies mature, not just in structure, but in chemistry. The Milky Way itself has aged like a living organism, gathering experience and complexity over billions of years. It is not a fixed thing, but a slow transformation. Written in atoms, the Milky Way is richer in metals than in the past. Astronomers call this metallicity, the abundance of elements heavier than helium. Our galaxy, once made mostly of hydrogen, now gleams with the traces of iron, silicon, calcium, and carbon. The stars born today are not pure like the first ones. They are blended, infused with history. Even our sun is a second, or third-generation star, its planets, including Earth, the product of many cosmic lifetimes. Metals, in astronomy, mean all elements beyond helium. In the language of astronomers, metal does not mean what it means on Earth. Anything heavier than helium, carbon, oxygen, nitrogen, is called a metal. The term reminds us that the early universe had almost none of them. It took billions of years of stellar burning to create the ingredients we now take for granted. When we say the universe has more metals, we are really saying it has learned more ways to build. Young galaxies are poor in metals, they are ancient. It sounds paradoxical, but in astronomy, youth and age reverse their meanings. The oldest galaxies are those formed soon after the Big Bang. They have few heavy elements, because few stars had died to enrich them. To look at them through a telescope is to see the early universe, simple, luminous, newborn. They are ancient in time, but young in chemistry. The universe's first drafts, written in pure hydrogen and helium ink. Old galaxies glow with gold and iron. As galaxies age, their light changes. The youngest, blue-white stars fade, leaving behind redder, older ones. Their accumulated metals, iron, nickel, carbon, give their light a warmer hue. These are mature galaxies, heavy with memory. They shine not in the innocence of youth, but in the wisdom of repetition. The golden glow of a galaxy is the color of experience, the light of a universe that has lived many lives. The cosmic web spreads these treasures everywhere. Across space stretches a vast network. The cosmic web, filaments of galaxies connected by dark matter and gas. Along these filaments, stellar debris drifts, enriching the intergalactic medium. Winds from supernovae, jets from black holes, and tides between galaxies all share the spoils of creation. The elements flow like rivers through this invisible web, ensuring that every corner of the cosmos participates in the same grand exchange. Even interstellar dust is chemical memory. Each grain of cosmic dust holds the imprint of its origin, the ratios of elements, the isotopes of its star, the scars of radiation. These grains are tiny archives drifting between worlds, surviving the death of stars and the birth of new ones. When they settle onto forming planets, they carry stories billions of years old. Interstellar dust is not waste. It is the handwriting of history, still legible if we learn to read it in light. Comets carry preserved samples from creation. Comets are time capsules, frozen since the dawn of the solar system. Made of ice, rock, and organic molecules, they preserve the chemistry of early space. When a comet approaches the sun, its ice sublimates, releasing a glowing tail, a temporary breath after billions of years of silence. Studying comets is like listening to the universe's first whisper, what it was made of, what it dreamed of becoming. Every meteorite is a message from the early solar system. Meteorites are fragments of that ancient time, pieces of asteroids and planets that never fully formed. When they fall to Earth, they bring with them unaltered samples of the past, minerals, isotopes, even traces of water. Some contain amino acids, the same seeds of life that once fell from the skies billions of years ago. Every meteorite is a letter written in stone, delivered late, but still perfectly intact. Every rock you hold is part of a billion-year chain. Pick up a pebble, and you are holding the universe's patience in your hand. It has cycled through mountains, oceans, and magma. It has been ash, crystal, and dust. Each atom within it has lived countless lives, once part of a star, perhaps, or the core of an asteroid. What seems inert is only resting, waiting for the next transformation. Rocks are the slowest storytellers of all. Matter never truly disappears. The conservation of matter is one of the universe's quiet promises. Nothing is ever lost, only changed. A body burns, but its carbon becomes air, a star explodes. But its iron becomes soil. The dance of atoms continues endlessly, rearranging themselves into new forms. Death is simply a new arrangement of the same eternal ingredients. It only changes its arrangement. Transformation is the nature of all things. Every molecule has been many things: cloud, mountain, creature, breath. Matter doesn't vanish, it migrates. It dissolves, reforms, and continues. Even the atoms in your body will someday drift apart, perhaps to build new worlds, new lives, new stars. The universe keeps no possessions, only patterns. Energy turns to matter, and matter back to light. According to Einstein's equation, energy and matter are two faces of the same truth. A photon can become a particle, and a particle can become pure energy. Stars convert matter into light every moment, while in the cold of space, light slows and condenses back into matter. Creation is not linear, it loops. Every atom of mass is frozen sunlight. Every beam of light is liberated matter. The elements dance in endless transformation. From fusion to decay, from creation to erosion, the elements move in rhythm. Hydrogen becomes helium. Helium becomes carbon. Carbon becomes life. And life, in time, becomes dust again. The universe is not a static sculpture. It is a flowing choreography of change. Nothing holds still, yet everything endures. The dance never stops. It only changes tempo. The universe is not static. It breathes. Galaxies expand and contract. Stars are born and die. Energy pulses through invisible fields. The cosmos inhales, drawing matter together, and exhales, scattering it into space. On vast timescales, this breath continues, shaping everything we see. The universe is not a machine. It is an organism made of light and gravity, endlessly oscillating between form and formlessness. And we are its exhale. Our atoms are the out-breath of stars, released, cooled, combined, awakened. To exist is to be part of that breath, to feel the universe moving through us with every heartbeat and sigh. We are not separate from the cosmic rhythm. We are the rhythm, condensed into thought and motion. When we breathe out, the universe breathes in again. And so it continues, the endless exchange between matter and meaning, between silence and song. Humans once dreamed of turning lead into gold. Long before laboratories, humans looked at metal and light and wondered if one could become the other. The ancient alchemists believed there was a hidden order, a secret pathway that could transform base matter into perfection. They were wrong in method, but right in spirit, because transformation is the nature of all things. What they sought through symbols and fire, modern science would one day achieve through understanding. The dream of transmutation never died. It simply evolved into physics. That dream became real through physics. In the 20th century, alchemy was reborn as nuclear science. By bombarding atoms with neutrons or protons, we learned to change one element into another, not by magic, but by energy. Gold has indeed been made from lead, though the cost is greater than the treasure. What matters is not the product, but the principle. Humanity finally touched the same forces that power the stars. We learned that the universe's most sacred transformations can be repeated by thought and will. We've created more than 25 artificial elements. Beyond uranium, nature makes no stable elements. Yet in our accelerators, we've forged over 24 new ones, from neptunium to oganesson. Some exist for milliseconds before decaying, but even that brief existence confirms our grasp of the atomic code. Each new element is like a new word added to the language of the universe, proof that understanding itself is a creative act. They live for fractions of a second. These synthetic elements flash into being, then vanish almost immediately, leaving only traces, isotopes, radiation, a faint signature of existence. Their short lives remind us how delicate balance truly is, how easily matter slips back into energy. Yet for that instant, they exist, new, unique, never before part of reality. In that flicker, human imagination merges with cosmic law. Yet they prove that fusion can be controlled. Every artificial atom, every nuclear experiment, proves something profound. The forces of fusion and fission, once confined to stars, can be understood and guided. In reactors, we split atoms to release energy. In labs, we join them to create new matter. The same processes that fuel the sun now illuminate our cities, power our instruments, and push our spacecraft toward the stars. Humanity has learned to borrow the universe's fire, carefully, reverently. Nuclear reactors mimic stellar reactions. Inside a reactor's core, neutrons collide and fuse, releasing immense energy as heat and light. Though contained and controlled, it is still the same principle that burns in suns. Humanity has built its own miniature stars, tamed by equations and cooling rods. The dream of fire no longer belongs only to the heavens. The stars lent us their secret, and we learned to hold it without being consumed. A fragile triumph of understanding over chaos. Particle accelerators recreate early universe conditions. When protons are smashed together at near light speed, the resulting collision releases energies like those that existed just moments after the Big Bang. In those brief instants, new particles appear, quarks, leptons, bosons, the same building blocks that once filled the newborn universe. Our machines have become windows into time, letting us watch creation replayed in miniature. To study these collisions is to glimpse the first seconds of existence itself. We have learned the patterns of the periodic order. The periodic table is not just a list. It is a pattern, a spiral of repetition and symmetry. From Mendeleev's first vision to modern quantum theory, we've discovered why the elements fall into place. Electrons, shells, and orbitals dance in a rhythm that repeats with precision. The universe's logic is mathematical, yet musical, structure and resonance entwined. We did not invent that pattern. We uncovered it, like an archaeologist brushing dust from a timeless design. Mendeleev saw the logic before it was complete. In 1869, Dmitri Mendeleev arranged the known elements by weight and properties, and in the gaps, he saw prophecy. He predicted missing elements, ones not yet discovered, and described their behaviors with uncanny accuracy. When they were found years later, they fit perfectly. Mendeleev had glimpsed the architecture of the cosmos through human intuition. His table was not invention but revelation, the stars whispering through numbers. His table predicted missing elements. Those gaps, like silent notes in a song, guided generations of scientists. Gallium, scandium, germanium, each one filled a missing piece, confirming the table's hidden symmetry. It was as if the universe had left clues, inviting us to read its logic. Every discovery since has followed that same trail, unfolding the periodic order like a map of creation. Scientists later found every one. Over the next century, as laboratories grew more precise, every one of Mendeleev's predictions came true. The table filled, extended, and evolved from mere dozens of elements to over 100. Each new discovery was both a triumph and a humbling reminder. We were tracing the universe's own handwriting, not writing it ourselves. The table became complete not because we finished it, but because we finally learned to listen. Chemistry became the bridge between stars and science. Through chemistry, the ancient art of alchemy was reborn in truth. It became the link between stellar physics and molecular biology, the middle ground where energy becomes structure and structure becomes meaning. From nebulae to neurons, the same principles apply: attraction, balance, transformation. Chemistry is the conversation between heaven and earth, between atoms and awareness. Even now, we search for islands of stability. Physicists believe there may be regions of the periodic table, theoretical superheavy elements, that could remain stable far longer than expected. These islands of stability would exist beyond our current reach. But their mathematics suggest longevity, maybe even utility. The search continues, a modern voyage across the periodic sea. Each experiment is a small ship, navigating the border between known and unknown, guided by curiosity and light. Future elements may yet surprise us. Perhaps there are forms of matter we have not imagined, elements that exist only in neutron stars or in the hearts of black holes. The periodic table we know may be just a single page in an infinite book. Discovery is not over, it never will be. The universe is too vast, too creative, too restless to be finished. Our understanding, like fusion itself, continues to expand. Our curiosity is a continuation of cosmic creation. When a star fuses atoms, it does so by nature. When a human studies that process, it is by choice. Curiosity is the next stage of evolution, energy turned into awareness. In us, the universe not only creates, but questions its own creation. Every experiment, every telescope, every idea is an act of the cosmos trying to understand itself. We, too, are forges of matter. In our reactors, we split and fuse. In our bodies, we synthesize and renew. Though our scale is small, the principle is the same. Inside each of us, cells transform atoms every second, turning food into thought, breath into motion. Life itself is alchemy, continuous and gentle. Whether in a laboratory or a heartbeat, transformation never stops. Our machines have become miniature stars. The reactors and accelerators of Earth hum with energy once confined to the heavens. They glow, vibrate, and release power that can light cities or unravel atoms. In these devices, humanity holds a mirror to the cosmos, recreating in steel and magnets what nature performs in gravity and flame. The boundary between natural and artificial dissolves. We are the stars, building stars. Humanity is the universe studying itself. Every calculation, every observation, every experiment is a moment of reflection, the cosmos turning inward. Through human eyes, the universe examines its patterns. Through human minds, it decodes its own rules. Awareness is the latest stage of creation, matter. Contemplating matter, energy understanding energy. In knowing ourselves, we let the universe know itself. We complete the circle of creation. The journey that began with the birth of atoms now finds its echo in the birth of understanding. The first stars created elements. We, their descendants, create knowledge. We have closed the loop, not by ending it, but by making it conscious. The stars once gave us life. Now we give them meaning. Creation has become self-aware. The cosmos looks back through human eyes. When you gaze at the night sky, remember, it is not only you looking outward, it is the universe looking inward. Every star, every photon, every molecule is part of the same whole, now reflecting upon itself through your awareness. The cosmos dreamed of consciousness, and through humanity, it achieved it. The circle is complete. The stars have learned to see. The universe began simple and became intricate. In the beginning, there was only light, pure, formless, without complexity. Yet within that simplicity lay infinite potential. Hydrogen emerged, then helium, then everything else followed. Over billions of years, the simple became layered. The quiet became music, and energy became memory. From nothing came everything. The story of the cosmos is the story of simplicity unfolding into consciousness, a flower blooming from a single spark. From hydrogen, it wove galaxies and minds. The smallest atom became the seed of all forms, stars, worlds, oceans, thoughts. Through fusion and decay, hydrogen gave birth to complexity beyond imagination. Even your brain, thinking these thoughts now, is built from the same hydrogen that first glowed in the newborn universe. Simplicity is not the opposite of depth, it is its beginning. From the first element came not only matter, but meaning. Every atom has traveled far beyond our knowing. Atoms do not rest. Over eons, they wander, torn apart by explosions, carried by winds, folded into stone, flesh, and air. The carbon in your body may once have been part of a comet. The oxygen you breathe may have drifted from another galaxy. The atoms remember their journeys. Even if we cannot, in their movement lies the eternal continuity of being, never lost, only elsewhere. The gold on your finger once floated in a nebula. That ring of light on your hand is not just a symbol, it is stardust solidified. Gold was born in the collisions of neutron stars, in bursts of unimaginable energy. For ages it drifted through the galaxy before finding its way to Earth. When you touch it, you touch the memory of cosmic violence that became beauty. Even luxury is rooted in destruction, creation's quiet paradox. The oxygen in your lungs once lit a star. Oxygen burns brightly, whether in a flame or in a fusion core. In the heart of long-dead suns, oxygen powered light that crossed galaxies. Now, that same element flows through your lungs, feeding the tiny fires of metabolism. You are breathing the light of the past, the same process, scaled down, softened, made human. The stars and you share the same rhythm: intake, release, renewal. The carbon in your heart may outlive the sun. Carbon is nearly eternal. When the sun expands and fades, much of its carbon will drift into space, intact, ready to begin again. The atoms that make your heartbeat will one day join that migration, continuing their journey through time. You may be gone, but your substance will not be. Eternity hides within the smallest dust. When you die, your atoms will scatter again. Your body will return to the earth, to soil, to air, to water. Each atom will find a new home, in a blade of grass, a drop of rain, a cell of another creature. Death is not the end, it is participation. You dissolve into the same cycle that once built you. The chemistry that formed your body continues its endless work, gentle, silent, sure. Someday, they may shine as light in another sky. Given time enough, those same atoms might fall into a new star, fusing again, glowing again. A piece of you could become a beam of light in another corner of the cosmos, seen by eyes not yet born. In this way, nothing is ever lost, only transformed. The future sky will shimmer with recycled souls. The cycle never ends, it only transforms. Creation and destruction are not opposites. They are two sides of the same rhythm, the pulse of existence. Every ending is an opening, every collapse a renewal. The atoms of a dying star become the breath of a living being. The breath of that being becomes the dust that seeds a new sun. The universe is not a line. It is a circle drawn in light. There is no true death in chemistry. Chemistry knows no final silence. Even decay is a form of dialogue, bonds breaking only to form anew. Matter never stops interacting, never stops rearranging. It dances endlessly to the laws of thermodynamics. Death is only a human word for what the cosmos calls transition, only rearrangement. The pattern changes, but the pieces remain. Your atoms will continue their journey, becoming rain, roots, rock, light. Rearrangement is the essence of eternity. The same material, infinite shapes. You have never truly begun, and you will never truly end. Only flow. Existence is fluid. Even the most solid mountain erodes, returns to dust, and finds new form in rivers, oceans, and clouds. Matter flows, time flows, life flows. The universe does not keep. It circulates. To resist is to forget our nature. To flow is to remember. The stars are ancient chemists. They work without hands, without haste, burning and fusing, balancing equations in flame. They have no need of purpose, yet their work creates it. Each star is both crucible and creator, an artist of atoms. They do not choose, but they give. Every element, every breath of wind, every heartbeat owes its existence to their labor. The galaxies are their laboratories. Vast and patient, galaxies are the stage upon which chemistry becomes art. Billions of stars mixing, dying, renewing, an infinite experiment running in parallel. From their collisions come nebulae. From their remnants, new generations of suns. Galaxies are not objects, but processes, immense, ongoing, never finished. And life is the experiment still unfolding. Out of dust and reaction came awareness, the strangest chemical of all. Life is the cosmos observing the results of its own experiment, adjusting, adapting, learning. Every thought, every act of kindness, every song, is part of the data. The universe studies itself through the chemistry of compassion. To exist is to participate in cosmic chemistry. Every breath, every step, every heartbeat is an act of reaction and exchange. You are part of a chemical continuum older than time itself. When you move, you stir atoms that once floated between stars. You are not separate from the cosmos. You are one of its ongoing reactions. To breathe is to continue the reactions of stars. Each inhale and exhale continues what began in stellar cores. Respiration is fusion, slowed and softened, the peaceful twin of a star's fire. Through you, the stars find new rhythm. The same energy that burns in the sun now whispers in your chest. To dream is to let matter imagine itself. In your dreams, matter turns inward, remembering its origins, rehearsing infinity. The atoms of your brain, forged in fire, now simulate worlds, memories, possibilities. Through imagination, the universe reflects on what it could become next. Dreaming is creation in miniature, a rehearsal for eternity. The elements are not just things, they are stories. Every atom is a narrative, of fusion, of travel, of transformation. To study them is to read the autobiography of the cosmos, written in invisible ink. They hold no words, yet they tell everything, of light, of patience, of endless return. And you, too, are one of them. You are not apart from the story, you are the story. Every heartbeat continues it, every breath rewrites it. You are made of ancient dust, burning briefly as consciousness before returning to the flow. The universe does not end, nor do you. You are eternal matter, dreaming, living, remembering itself through time. And now, the story folds back into stillness. The fire that once burned in stars now cools in your veins. The same hydrogen that began everything still flows, unchanged, just rearranged, just quieter. Look around you. Everything you can touch, see, or feel. The air, the stone, the warmth in your chest. All of it has lived before. Every atom has wandered through suns and seas, through time and transformation, through birth and dissolution and birth again. Nothing is ever lost. Not light, not matter, not you. You are the continuation of an ancient experiment, a single note sustained in the long music of existence. The stars once wondered what they could become, and one day, they became you. So rest now. Let the chemistry quiet itself. Let the pulse of the cosmos slow to match your breathing. You are made of eternal matter. And eternal matter never ends. It only changes form. It only changes song. Close your eyes. Let the universe exhale through you. Let the elements return to silence. You have always been home among the stars. And tonight, the stars are dreaming through you.